Okay, this video is for a sub lesson plan. We've been talking about lines quite a bit in class, and today we're going to spend a little bit more time on slope. And hopefully, we remember that we've been dealing with the equation of a line y equals mx plus b, and hopefully we know that the b is the starting point, and that's where it hits the y axis. And now we're looking today more closely at slope. And slope, hopefully we remember, is the change in y over the change in x. We said it's rise over run. And hopefully we remember that we said that if the slope is positive, we typically go up. If it's negative, we typically go down. And we typically try to go to the right. So hopefully all that rings a bell with what we discussed. I'll let you guys read this, but essentially it has to do with a race in the Olympics where you swim for a bit and then bike for a bit and then run for a bit. And they make the point that the guy that won the gold medal one year actually wasn't even in the top 10 at the first part of the race, but he ended up winning the race because he was better at biking and running than the other people were. So if we look at that, we have biking the triathlon. The second part of a triathlon is a bicycle race. Since participants do not start the bicycle race until they complete the swimming portion, the bicyclists have varying starting times. The graph below shows information about 4 bicyclists during a 20-minute portion of the race. So we have some questions for 743 and some graphs to go with it. So it says, based on the graph above, list the bicyclists from slowest to fastest. How can you tell? Well, I think we're looking for a steep slope, right? So I think B is probably the fastest. From there, it's a little bit hard to tell for me, honestly. I could be wrong on this. I'm just sort of eyeballing this, but I really look like A and C are going darn near the same speed. It's kind of hard to tell here, so I guess I'll just say A first, then C second. I'm not sure. And then it looks like D is a little bit slower than both of those. Again, I don't know. I haven't actually looked at this yet. If I'm eyeballing it wrong, I apologize. So Lydia wants to describe each bicyclist's rate in kilometers per minute for an article in the school paper. To do this, she sketched triangles like the one in line A on the graph. And you can see, I don't like when they do it this way. I like to do rise over run. I like to actually go up 4 and over 6. Hopefully that makes sense. But I like to do this one first and this one second, because this will be the top of a fraction and this will be the bottom of a fraction. Hopefully that makes sense. Anyways, to do this, she sketched triangles. Where do the 4 and the 6 come from on the racer's triangles? What do they represent? Well, 4 represents 4 kilometers, right? That's how far she went, and 6 represents 6 minutes. So she apparently, or he, I don't know, went 4 kilometers in 6 minutes. Hopefully that makes sense. These numbers can be written as a rate in kilometers per minute to describe the distance a bicyclist rides as time passes. The fraction 4 over 6 represents how the graph of the line goes up 4 units for every 6 units it moves to the right. The number called 4, 6 is the slope. Again, this is our change in y, 4. This is our change in x, 6. Did the slopes in part C confirm your ranking? Oh, okay, I must have missed something. Find the slope of each of the other 3 lines. Okay, so they gave us some numbers here. So this one, it looks like it's up 2 and over 3. So for C, I would say it's 2/3. For B, it looks like it's going to go up 3 and over 3. So 3/3. And then for D, it looks like we're going to get up 2 and over 4. So 2/4. So did the slopes confirm what I thought? Well, let me see here. This one I had 4, 6. Yeah, I would say it did. I have B as the fastest. I wasn't sure between A and C, and it looks like they actually tied because 4, 6 is the same as 2/3. So it looks like that's the fastest one. These ones are tied for second, and this one is going to finish 4th. So I would say yes. Now, moving along here. It says, look at your Biking the Triathlon resource page 743. Slope can also be thought of as a unit rate. Remember that a unit rate compares the change in one quantity to a 1 unit change in another quantity. Find the unit rate for each of the triathlon bicyclists. Make sure to to label your units? Well, if I'm going to go unit rate, essentially what I'm going to do here is I'm going to divide 2 by 3. And I hope we all know that if you divide 2 by 3, you're going to get 0.6 repeating kilometers a minute. That's for A. So I'll put that over here. A is 0.6 repeating kilometers a minute. For B, we're going to get 1 over 1, so we're going to get 1 kilometer a minute. For C, again, 2 divided by 3 is 0.6 repeating kilometers a minute. And then finally for D, 2 divided by 4 is just going to be 0.5 kilometers a minute. So that's going to be our unit rate. That's how far we move in 1 minute. And then write each of the bicyclist rate as a decimal rounded to the nearest hundredth of a kilometer. When you order the bicyclist rate, do you get the same results as 743? Yeah, I still have B is the fastest, A and C were similar, and then D appears to be the slowest. So when comparing the rates from problem 743, a study team is struggling to decide how to tell which athlete is moving faster. Leo thinks because athlete A's line is highest on the graph, he's traveling faster. Kara disagrees. He starts first, but racer B is moving faster. Which person do you agree with? Well, I would definitely agree with Kara. It's true that everybody, A, C, and D started earlier than B, but B is definitely moving faster. So I would say Kara is moving faster. I'm sorry, Kara is correct. Kara is correct. And B is fastest. It looks like what's going on is that B just got a late start, right? We talked about getting out of the water later and running later, so it looks like that's what happened to B. 746 in chapter 4, problems 4.8 through 4.10. You looked at how patterns grow. You examine how the growth rate could be seen in the table, graph, and rule for the pattern. One of the patterns that you looked at and its graph are shown below. So we have this, we have a graph. What we could do is we can even make a table if we wanted. Probably not a bad idea. So 0 has 2 blocks in it. 1 has 6 blocks in it. 2 has 6, 7, 8, 9, 10. And 3 has 8, 11, 14. So it looks like it's adding 4 each time. So what is the growth rate for this pattern? It looks like it's grown by 4. And what is the slope of the line on the graph? Well, it better be 4, right? So we're going 0, 2, up 4, over 1, up 4, over 1. So we've discussed that a bunch of times, right? We should be able to see it in the table. We should be able to see it in the graph. And we should be able to see it in the equation, which, by the way, the equation there is 4x plus 2, right? And we can plug in 3 to check that. 4 times 3 is 12, plus 2 is 14, so we feel pretty good about that. So we should be able to get that for all of them. Mr. Rayner's class has been struck with hiccups. 3 of the students track their numbers of hiccups over time. Assume each student hiccups at a constant rate. So which student has the most hiccups per minute? Well, on this one, it looks like they're going 8 for every 2. And it looks like they're going 12 for every 3. Well, 8 divided by 2 is 4 hiccups a minute, and 12 divided by 3 is 4 hiccups a minute. So this one, we're getting 4 a minute. Hopefully we're okay with that. This one, it looks like we're going up 7 and over 2. Well, up 7 over 2 is the same as 3.5 over 1. So this would be 3.5 every minute. And this one, it looks like a giant mess, but it looks like we're going, oh, it's up 3.8 and over 1, so not quite 4. Up 3.8 over 1, up 3.8 over 1. So that's 3.8 hiccups a minute. So hopefully we're okay with that. We figured that out, the unit rate per 1. So which student has the most hiccups per minute? I'll say student 1 does. Find the slope that determines the rate of hiccups for each student. I did, right? The slope here is 4 a minute. The slope here is 3.5 a minute. And the slope here is 3.8 per minute. What does the slope tell you about each student? I mean, it tells us how many hiccups per minute. And then if you graph the line for the student who hiccups 4 times per minute, would the line be steeper, less steep, or the same steepness as the graph line student 2? Well, it would be steeper, right? Because this is going up 7 for every 2, but this should go up 8 for every 2. So it'd be a little bit steeper. We'd be going up 8 and over 2. So we'd say it's a little bit steeper. Additional challenge, changing lines. Lupe is a manager of an assembly line at a manufacturing company that makes cars. The speed at which the cars are usually built is represented by the graph below. So we have this graph here. It says Lupe has decided to increase the number of cars built each day and has written directions for her employees. How would each of her directions below change the number of cars built each day? Explain how you know. So we have the number of cars and we have the time. So if we built 200 cars every 4 hours, there's 200 cars every 4 hours, 200 cars every 4 hours. Looks like A would slow it down. Right now we're building, let's see, a lattice point. It looks like we're building 300 cars every 4 hours. That's 75 cars an hour. That's how much we're building right now. But she wants to slow it down to 50. So that would be slower. Build 75 cars every hour. We said we're already building 75 cars every hour, so that would keep it the same. Build 500 cars every 5 hours. That would be 100 cars an hour. So that would speed it up. And then decrease the time it takes to make each car. Well, if you decrease the time, you should in theory be going faster, right? So if we look up here, if I go ahead and erase some of this here and clear it up, if we say, all right, we're going to build the same amount of cars, we're going to build 300 cars, but now we're only going to do it in 3 hours, you can see that gets a little bit steeper. And 300 divided by 3 is 100 cars an hour, which is faster than the 75. So we would definitely say that would speed it up as well. I hope that helped. Now you can move on to your homework.